Okay, today I'm going to discuss with you the rectangular hyperbola referred to its axis as the asymptotes. That means the y-axis and the x-axis will become the asymptotes to the rectangular hyperbola, and the transverse and the conjugate axis will be along the asymptotes given by y is equal to x and y is equal to minus x. Now for a rectangular hyperbola, x square minus y square is equal to a square. We know that asymptotes are given by the equation y is equal to x and y is equal to minus x. Now from here you can see that the slope of this first asymptote is 1 and the slope of the second asymptote is minus 1. And if you take the product of their slope, it will be 1 into minus 1 is equal to minus 1. That means the two asymptotes are perpendicular to one another. So from this figure you can see that if this is the hyperbola x square minus y square is equal to a square, then the asymptotes are given by this line which passes through the origin y is equal to x, and another one is y is equal to minus x. Now in this case we need to find the equation of the new asymptotes of rectangular hyperbola when the transverse axis of x square minus y square is equal to a square, that is this one, now become the asymptotes to that hyperbola, and also the conjugate axis of this hyperbola x square minus y square is equal to a square also become the asymptotes to that new hyperbola. So now here what we need to do is, let us find out that new equation, but we know that these two asymptotes y is equal to x and y is equal to minus x are perpendicular to one another. So now let us find what will be the equation of that asymptotes. So here let us, from this figure, what we notice is that the asymptotes of x square minus y square is equal to a square are that one, y is equal to x and y is equal to minus x. Now I can write this one as y minus x equal to 0 and y plus x is equal to 0. Now the combined equation of these asymptotes is given by y minus x into y plus x is equal to 0. So the combined equation of the asymptotes of x square minus y square is equal to a square is y minus x into y plus x is equal to 0, which gives you y square minus x square is equal to 0, or x square minus y square is equal to 0. So now what we notice from here is that the equation of the rectangular hyperbola is x square minus y square is equal to a square, and then the combined equation of the asymptotes is x square minus y square is equal to 0. What we see from here is that the difference between the equation of the rectangular hyperbola, this one, and the combined asymptotes of this one is by a constant only. So that means if you know the equation of the rectangular hyperbola, then you can always find out the equation of the asymptotes using these steps. Or if you know the equation of the asymptotes, then you can find out the equation of the hyperbola, because the combined equation of the asymptotes and the equation of the hyperbola only differ by a constant. So now by using this figure, we need to show that, because according to this one, the asymptotes is y is equal to x and y is equal to minus x, but by the given condition is that the y-axis and the x-axis now are the asymptotes to the new hyperbola. So now the transverse axis is y is equal to 0, but this one become the asymptotes to that new hyperbola, and x is equal to 0, which is a conjugate axis, also become the asymptotes to that new hyperbola. So now when we refer the x-axis and y-axis, that means the transverse axis and the conjugate axis, as the asymptotes to the hyperbola, then y is equal to 0 and x is equal to 0 are the equations of the asymptotes are the equation of the asymptotes of that hyperbola where the transverse axis is no more the x-axis and the conjugate axis also is not the y-axis, but instead the x-axis become the asymptote, the y-axis also become the asymptotes. So therefore the equation of, for the x-axis we know that equation is given by y is equal to 0, and for the y-axis the equation is x is equal to 0. So that means these are the equation of the asymptotes to that hyperbola when we refer to its axis as the asymptotes. Now what will be the combined equation of these asymptotes? Combined equation of these asymptotes is yx is equal to 0, or xy is equal to 0. Now we know that from the discussion that I have given you just now, that the difference between the equation of the hyperbola and the combined equation of the asymptotes is only by a constant. So now since we know that this one represents the combined equation of the asymptotes to that hyperbola when referred to its axis as the asymptotes, then in that case what will be the equation of that hyperbola? Then equation of the hyperbola is xy equal to k, where k is a constant. So k is a constant in this case. Now let us find out what will be the value of this k. But we know that from this figure, the point of intersection of this new hyperbola which meets the asymptote y is equal to x is this one, a by root 2, a by root 2. That means the vertex of this hyperbola on the line y is equal to x will be a by root 2, a by root 2, because the angle made by this asymptotes with the x-axis is 45 degree. So let us see now from this one, since this hyperbola xy is equal to k passes through this point a by root 2, a by root 2. So in that case we can calculate, since xy is equal to k passes through a having the coordinate a by root 2, a by root 2. That is the vertex of that hyperbola whose asymptotes are the x-axis and the y-axis. That is this point here. So what will be, you replace this one x by a by root 2. So a by root 2 into a by root 2 is equal to k, which means that k is equal to a square by 2. So the value of k now is equal to a square by 2. Or we can write now xy is equal to a square by 2 is the required equation of the rectangular hyperbola when we refer the x-axis and the y-axis as the asymptotes of that hyperbola. So this will be that the figure of that hyperbola will be this one and this. So it will be given by the equation xy is equal to a square by 2. Or I can write it as xy is equal to c square, where c square is equal to a square by 2. So this one gives you the equation of the rectangular hyperbola when we refer to its axis as the asymptotes. And the transverse axis in this case will be this one, a prime, which is along the line y is equal to x, and the conjugate axis will be this one, which is y is equal to minus x. So this is the method of finding the equation of the rectangular hyperbola when we refer to the y-axis and the x-axis as its asymptotes. And the equation is given by xy is equal to c square, where c square is equal to a square by 2. Now let us come to these problems related to this equation of the how to find the equation of the asymptotes. Find the equation of the hyperbola which passes through a given point and has the asymptotes 4x plus 3y minus 7 is equal to 0 and x minus 2y minus 1 is equal to 0. Now here it's given that we need to find the equation of the hyperbola, and that hyperbola is given to pass through the point 2, 3. And the asymptotes are given to be this one, 4x plus 3y minus 7 equal to 0 and x minus 2y minus 1 is equal to 0. Now given equations of asymptotes are this one, 4x plus 3y minus 7 is equal to 0 and x minus 2y minus 1 is equal to 0. This is 1 and 2. So these two represent the equation of the two asymptotes to that hyperbola which passes through the point 2, 3. Now what we need to find is the equation of the hyperbola using this given equation of asymptotes. Now you can find out what will be the combined equation of the asymptotes. We know that the combined equation of the asymptotes and the equation of the hyperbola only differ by a constant. So it's enough for us to find first the combined equation of the asymptotes. So combined equation will be this one. It will be 4x plus 3y minus 7 into x minus 2y minus 1 equal to 0. So you multiply these two equations of the asymptotes. The right hand side term will be multiplied together and the left hand side term also will be multiplied together. So we have this one. So it gives you 4x square minus 8xy minus 4x plus 3yx minus 6y square minus 3y, then minus 7x minus 7 into 2 will become 14y, minus into minus plus 7 equal to 0. Or 4x square minus 6y square. Now 8xy plus 3xy minus, this will become minus 5xy. Then minus 4x minus 7x will become minus 11x. Then minus 3y minus 14y, this will give you minus 17y. Then plus 7 is equal to 0. So this one represents the combined equation of the given two asymptotes. Now since the equation of the hyperbola and equation of the asymptotes differ only by a constant, so it means that equation of the hyperbola, required hyperbola, will be this one, the same one, 4x square minus 6y square minus 5xy minus 11x minus 17y plus 7 is equal to, let us denote it by C1, a constant. So this will be the equation of the hyperbola. But it's given that this hyperbola passes through the point 2, 3. So it means that this hyperbola passes through 2 and 3. So using this given condition, we can find out the value of C1. So you replace x by 2 and y by 3, then you'll get 4 into 2 square, 4 into 2 square minus 6 into 3 square minus 5 into 2 into 3 minus 11 into 2 minus 17 into 3 plus 7 equal to C1. Or this one will be 4 into 4, it will be 16 minus 9 into 6, it will be 54 minus 5 into 6, it will be 30 minus 22 minus 51 plus 7 is equal to C1. So let us see what will be the value of this. 16, okay, minus 54 minus 16 minus 30, it will give you minus 14. Minus 14 plus 7, it will become 7. So 7 minus 7 minus 54 minus 22 minus 51. So we can cut, this will be equal to C1. So what will be the value of C1 now? It will be 54 with this one, it will be 105. 105 with 22, it will become 127. With 7 here, then it will become 134. So that means minus 134. So the value of C1 now, C1 is equal to minus 134. Therefore, the required equation of the hyperbola will be this one. It will be 4x square minus 6y square minus 5xy minus 11x minus 17y plus 7. Then instead equal to C1, it will be minus 134. Or you can bring it to this side, then it will become plus 134 equal to 134 plus with this 7, then it will give you 7 4 will be 11, so it will be 141. So finally it will be plus 141 equal to 0. So this will be the equation of the hyperbola. From how you are getting this equation of the hyperbola? From the combined equation of the asymptotes. And from the combined equation of the asymptotes, we know that the difference between the equation of the hyperbola and the combined equation of the asymptotes is by a constant term only. So you write that equation of the hyperbola equal to some constant c from the combined equation. And since by the given condition also that hyperbola passes through a point 2 and 3, then from there you can evaluate the value of c1. After getting the value of c1, then you can substitute in that equation of the hyperbola. So finally the required equation will be this one.